So today we're going to start a new section. This one is about polygons on the coordinate plane. Before we jump into the lesson, I want to go back and review a little bit about graphing on the coordinate plane. So here I have a graph for you. And if you don't have graph paper, don't worry, I have a solution for you that you can still do this and have access to some graph paper even if you don't have any at home. So here's our coordinate plane. Remember, co means together, order. So there are two numbers that are ordered together to get us our location on the plane. So right here in the middle, where the two axes intersect, we call it the origin. Remember that side to side, this is our x-axis all the way here, and up and down, this is our y-axis. Remember that this is the positive side of the x, and this is the negative side. Going up is the positive for the y, and going down is the negative. So in the order, remember they go alphabetical order, if I was to graph the point 3, -2, start at the center point, the origin, go side to side, +3. So we'll come over 1, 2, 3. And then we would go up and down, -2. 1, 2, 3, 1, 2. There's my first dot. Make the dot. And then you can label it with whatever letter. I didn't have letters on this, sorry. All right, let's do another one. We're going to go -4, 1. So again, go back to the center. Go side to side, -4. 1, 2, 3, 4. And then up and down, +1. Make your dot. Label it. And then a final one here, we're going to go side to side 5, 1, 2, 3, 4, 5, and then up and down 0. So that will sit directly on the x-axis. Now, if you're asked to do quadrants, remember that we start up here in quadrant 1 where everything was positive, and then we go around like a C. So this would be quadrant 2, quadrant 3, and quadrant 4. So point A was in quadrant 4, point B was in quadrant 2, and we would say that point C sat on the axis. All right, so that was a quick little review of some graphing. Now let's go talk about what we're doing with the topic. Let me zoom in a little bit here. I'm going to be on page 706 in your book. We're going to break this into at least 2, maybe 3 days because there's lots of topics and I want to take it slow and make sure you get it. So today we're going to talk about things with straight lines. Tomorrow we're going to talk about some things with some slanted lines. One of the reasons that I'm breaking it up so you don't have to do too much at once. The word vertices is plural for vertex. And that you know a vertex is the corner. So here we have 4 vertices. This is the top left vertex. Okay, it's just singular and plural for the same word. They've given us some numbers here. This is all going to be in quadrant 1. They've given us some numbers and they've already graphed it. There is a technique that I'm going to show you an example too that you don't have to graph it. I understand some people are visual learners. That's me. And I'll show you a website that you can use to help with that. So you're going to take these points, you're going to graph them, connect them, make your polygon. In this case, our polygon is a rectangle. Helpful to know that because you know the sides across from each other are equal. Okay, if they just said here, plot the polygon, you're not quite sure what it is and you kind of really have to graph it, but knowing that it's a rectangle does help. Now, they ask us to find the perimeter, and perimeter is like a fence. It's the lines that you would draw. So one side here is 3, 5, 3, 5. If that wasn't shown to you, how could you figure it out? You start at one of the points and you count the boxes. 1, 2, 3, 4, 5. 1, 2, 3. And then because it's a rectangle, we can assume that the sides across from them are going to be the same. Now there's some notation that they're using here. This AB with the line over top of it means line segment. So the points A and B, the segment between it, and you guys probably call it a line, it's not really, but the segment between those happens to be 5. So segment AB is 5 units long. Units because we don't know if they're inches or feet or miles or whatever. And similarly, CD going down here is also 5. And then BC this way is 3. And DA, they went up instead of going down. The order doesn't matter, is 3. So adding them all up, the perimeter or the fence for this rectangle is 16 units. So you can graph the points that are given, figure out the length of the side, and then add them up. Everything we're doing today is perimeter, so you're going to be adding. Okay, so we're going to look at example 2 here. We've got a rectangle ABCD. That tells me that the corners are going to go in order. So A, and then if I traced it around, so that would be A, then B, then C, then D. It follows around in a rectangle. I could graph this. And if you're a visual learner like me, you're reaching for your graph paper right away. But there's a way to do it without graph paper that might save you a whole lot of time. Look at the coordinates. So in this case, the x-coordinate is the same for A and B. I went over 2 for both of these. And if I look at C and D, the x-coordinate is the same for both of those. That means that I went over the same amount. And I went over the same amount. So those two pairs drew my vertical lines. Now let's look at the y-coordinates. If I look here, B and C have the same y-coordinate. And if I look at A and D, they also have the same y-coordinate, which means we went up 1 for both of them. That second A and D pair made the bottom line. And we went up 5 for both of them. So B and C made the top line. You can actually subtract the coordinates to find out the length of the sides. Okay, so let's look at these as a pair. So from A to B, the thing that has the same x coordinates, we're going to subtract 5 and 1. Let me show you that down here. 5 minus 1 is 4. Okay, same thing here. The ones that have the same x coordinate, we're going to subtract 5 and 1. I get the same each way. So that means that this side and this side are 4. And then we'll go to the ones that have the same y coordinate. So these two, and we'll subtract the other numbers. So 4 minus 2 is 2. Oh, that's a badly drawn picture. And then the same y coordinate, 4 minus 2 is 2. Add those up, 4 plus 2 plus 4 plus 2. You've got 12 going all the way around. Now, that's a little crazy because you've got all of these numbers. Sometimes I'll write them vertically like this and then kind of chunk them. So if I'm going to do these two, right, because I see the same x, then I would just subtract 5 and 1. But then if I see these two that have the same y, then I just subtract those. And the beautiful part about a rectangle, if I know that this is 4 and I know that this is 2, I know the other sides are the same measures. Okay, so if you can wrap your head around how to do it this way, it's actually super, super fast. Okay, let me show you this site. It's called Desmos, DESMOS.com. I'm actually going to use these coordinates again, and I'm going to show you how it works. So it's desmos.com, go here, /calculator, and I have this link in today's post. It has us zoomed out quite a bit so that each one of these lines is actually 2. I'm going to go over here to the plus where I zoom in. Now each one of the big lines is 1, and they have some smaller ones so you can do fractions and decimals and things. Set it the same way that my grid was on the paper. And then you've got this typing box over here. All right, so I'm going to use the exact same problem, the exact same coordinates from example 2. I'm not going to label with the letters. I'm just going to use the numbers. So A was 2 comma negative 1. See this here? 2 comma negative 1. I type that in. It made me a dot. I went over 2 and up 1, and there's my dot. Okay? You can label it if you really wanted to. Okay. Then the next one, you just click below it. The next one, B, was 2 comma 5. 2 comma 5. Label that one B. C was 4 comma 5. And D was 4 comma 1. C, D, you can even move this. There they are. I was zoomed out a little much. Okay, so here's my origin again. Take this back. Right. There is the same rectangle that we just did. So if you're a person who needs to see it, you've got everything you need now. This, we're going to go from here 2 to 4 is 2 jumps. And then 1 up to 5 would be 1, 2, 3, 4. You're counting the big blocks. Don't worry about the little blocks there. Okay? And then when you're ready to do another problem, you can just X all these out, and then you've got it clean back up. If you need to zoom in or zoom out or do anything that you need to do, that is an option for online graph paper. You don't have to worry about killing trees. You don't have to worry about printing anything out. it's there for you. And then tomorrow, when we get into some more sophisticated shapes and finding area, you can use this to see the shapes from that. Okay? All right, I'm going to jump back to the book. You might want to try the got it's at the bottom of the page. I don't need that. There we go. We'll go back to the got it to the bottom of the page. I want to shift over to the next page. They've given us everything we need. It's not a traditional rectangle, but you've got all of the points graphed. The one thing that I want to point out to you, because this trips a lot of kids up, you have to read the problem. It said each grid on the zoo map has a length of 200 feet. That means that one little block here is worth 200 feet. So there's an extra step involved in this. Now, if you're like me, you're going to go count, and that's totally fine. Some of you might try the subtraction. Most of us are probably just going to count. So if I look up here, we're going from 0 to 7, kind of subtraction. You can count if you want. That top line is worth 7. This is 1, 2, 3. This is 1, 2, 3, 4. 1, 2, 3, 4. 4, 3, 7. You're seeing some repeats because they really are like rectangles, where this top one and the bottom one, where this top one and the bottom one here. And then here we go from 0 to 10, so that side's going to be 10. Okay, the numbers are all here. That's where they got those numbers. So they added them up. 10 plus 7 plus 3 plus 4 plus 4 plus 4 plus 3 plus 7 gave me 42. The perimeter of this is 42 units. But that's not the answer. Because if you remember, each one of these little boxes is worth 200 feet. So they took the 42 lines, or little pieces, multiplied by the 200 feet that each represents, and the total perimeter is going to be 8,400 feet. One of the problems that I ask you to do today is similar to this. So pay attention, make sure you read the problem. All right? So you can graph, you can subtract, and then you have to be careful to make sure that you are representing your answer properly.